Now we'll see a problem in quantum mechanics. I have taken this problem from Introduction to Quantum Mechanics by Griffiths and Sherother. Calculate the expectation value of x squared, p squared, sigma x and sigma p for the nth stationary state of the infinite square well. Check that the uncertainty principle is satisfied. Which states comes closest to the uncertainty limit? So the nth stationary state of infinite square well has the wave function psi of x comma t is equal to square root of 2 by a sin n pi x by a e power I n squared pi squared h cross divided by 2m a squared into t. Now you have to find out the expectation value of x. So expectation value of x is integral psi star x psi dx. Now substitute the value for psi and psi star, we will get 2 by a integral from 0 to a x sine squared n pi x by a dx. This sine squared you can write it as 2 sine squared theta is 1 minus cos 2 theta. So it is 1 by a integral from 0 to a x into 1 minus cos 2 n pi x by a to dx. So it is 1 by a integral from 0 to a x minus x cos 2n pi x by a dx. So first term you can integrate, that is x squared by 2. Second term it is x cos 2n pi x by a. So the second term it's like integral u dv. Integral u dv is uv minus integral v du. So you take u as x, dv as cos 2n pi x by a. So du is dx, v is minus 2a by 2n pi sine 2n pi x by a. So the integral from 0 to a x cos 2n pi x by a dx is minus a by 2n pi x sine 2n pi x by a. We have to substitute the limit 0 to a, then plus a by 2n pi integral from 0 to a sine 2n pi x by a dx. So if you substitute the limit, the first term will be 0 and the second term, once again if you integrate, it is minus a by 2n pi the whole square cos 2n pi x by a, substitute the limit 0 to a. If you substitute the limit, this will be 0. So the expectation value of x is a by 2. Now you have to find out the expectation value of p. Expectation value of p is psi star integral psi star minus I h cross dou by dou x psi dx. So it is like integral from 0 to a sine n pi x by a, the differentiation of sine n pi x by a. So it is like x dx. So after integration it is sine squared n pi x by a divided by 2. So substitute the limit, we will get it is equal to 0. And also we can directly take it from m differentiation of expectation value of x with respect to time. That's also equal to 0. Next we can find out the expectation value of x squared. So this x squared, it is integral psi star x squared psi dx, and substitute the value, and also we can get it is 2 by a integral from 0 to a x squared sine squared n pi x by a dx. Once again you are writing 2 sine squared theta as 1 minus cos 2 theta, and once again integrating, and also you are following integral u dv formula. Here u is x squared and dv is cos 2n pi x by a, and du is 2x dx, and v is minus of a divided by 2n pi sine 2n pi x by a. And also if you substitute the limit, the first term is 0, the second term once again you have to integrate, it is x sine 2n pi x by a dx. Once again use u integral u dv formula, then we will get it is equal to a divided by 2n pi x cos 2n pi x by a. Substitute the limit 0 to a, and minus of a divided by 2n pi integral from 0 to a cos 2n pi x by a dx. So in the first term you have a divided by 2n pi into a. The second term it is minus a divided by 2n pi whole squared sin 2n pi x by a. Substitute the limit 0 to a. So that second term is 0. So we will get a squared divided by 2n pi. So using equation 10 and 11, equation 8 becomes the expectation value of x squared is a squared into 1 by 3 minus 1 divided by 2 into n squared pi squared. Now you have to find out the expectation value of p squared. So it is integral psi star p squared psi dx. P in the operator form is minus I h cross dou by dou x. So it is like minus h cross squared integral from 0 to infinity psi n star dou squared psi n by dou x squared. And if you use the Schrödinger equation inside the well where v is equal to 0, so you use the time independent Schrödinger equation, that is En is equal to minus h cross squared divided by 2m dou squared psi n by dou x squared. So instead of dou squared psi n by dou x squared, you can write it as 2m by h cross squared En. So this is like 2m En, and En value, the energy value is n squared pi squared h cross squared divided by 2m a squared. So if you substitute all, we can get the expectation value of p squared is n squared pi squared h cross squared divided by a squared. So now you have to find out the uncertainty in x. It is sigma x equal to expectation value of x squared minus square of the expectation value of x whole power half. And using equation 3 and 12 and substitute in 15, then you can get sigma x is a by 2 1 by 3 minus 2 by n pi whole squared whole power half. Similarly, for uncertainty in p, it is expectation value of p squared minus square of the expectation value of p whole power half. So using equation 6 and 14, and then sigma p is n pi h cross by a. Now we have to check whether it is consistent with the uncertainty principle. So sigma x, sigma p is, substitute the value, then we will get it is n pi h cross by 2 1 by 3 minus 2 by n pi whole squared whole power half. So if you substitute n is equal to 1, then we will get it is n pi h cross by 2 into 1 by 3 minus 2 by pi squared whole power half. So it is greater than h cross by 2. So when n is equal to 1, this is consistent with the uncertainty principle. Thank you.